Hello everyone. Today we are going to see about medical images obtained with non-ionizing radiation. First, let us understand what does non-ionizing radiation means. Non-ionizing radiation means it is the low energy radiation. It does not have energy to remove the electrons from atoms. The equation is E equal to hv, but the frequency here is low, so the energy is also low. Example includes radio waves, microwaves, and sound waves. It was safe for the repeated and clinical uses. Now, why do we prefer non-ionizing methods? Because ionizing radiation has risk, DNA damage, cancer risks. So the goal is to save diagnostic imaging. That means we want information without harming the patient. So ionizing just solves why this use safer forms of energy, and the safety is the main motivation here. Now let us understand how these technologies were developed. First one is empathize, understand the patient and doctor needs. Second one is define. Clearly, I define the imaging problem. Examples need to image brain safely. So the MRI is developed. The important idea is in engineering starts with understanding the problem first. Next stage is for the ideate, generate the solution, and prototype, build the imaging systems, test this, check safety and accuracy. This is the continuous process. Important idea is imaging modalities are results of iterative motivation. Non-ionizing imaging is classified based on the type of wave interaction. There are three main types: magnetic resonance, MRI, and acoustic waves, that is ultrasound, and optical methods, light-based imaging. Different waves interact differently with the tissue, so the different physics, different image formation is there. Now let us deeper into the MRI. Core concept is nuclear magnetic resonance has the formula of omega equal to gamma B naught. This is the Lamarck frequency. Human body has hydrogen atoms. These protons behave like a tiny magnets. When placed in the magnetic field, they align them. We apply radio frequency pulse, disturb them. They turn back, emit signals. So the signal comes from the atomic spin behavior. That's why MRI gives very detailed soft tissues images. Now, how is the signal is formed? Step by step, RF pulse excites the protons. Protons relax back. During relaxation, signal is emitted. Two types of relaxation. T1, longitudinal, T2, transverse. So the different tissues relax differently. That creates the contrast. Example, fat with water behave differently. So the MRI contrast depends on the relaxation differences. Now, ultrasound. Core concept is acoustic impedance. Z equal to rho C, where rho is the density and C is the speed of sound. When sound travels through the body, it reflects at boundaries. Example, tissue to fluid, organ boundaries. Important idea is echo strength depends on a tissue difference. So the image is formed from reflected sound waves. Ultrasound has different modes: A mode, B mode, and Doppler mode. A mode shows the amplitude, simple 1D signal. B mode is the brightness mode, gives 2D image, most commonly used in pregnancy imaging. Doppler measures the motion, blood flow. Ultrasound can show both structure and motion. That's why it is widely used in pregnancy and heart studies. Now, optical imaging. It uses visible or infrared light. Light interacts with the tissue by absorption, scattering. The problem is light cannot penetrate deep into the body, so depth is limited, but resolution is very high. Key idea is high resolution but low penetration. Two main techniques: endoscopy, camera inserted into the body, direct stimulation, and OCT, optical coherent tomography, uses light interference, gives micro level detail. You use for surface or near surface imaging. Example, gastrointestinal tract eye imaging, like that. There are three types of non-ionizing radiation is used. That was MRI, magnetic resonance imaging, ultrasound, and optical imaging. Here the signals are used here. In MRI, RF signal is used. In ultrasound, echo is used. And there is a physics behind this is in MRI, resonance is the physics, and ultrasound reflection, and optical is light interaction. So the output of from this non-ionizing radiation is both from structural and functional. It it has the safe energy, so it does not harm the DNA like that, so that it is very safe for diagnostic images. So These are the references. Thank you.